Hi, I'm Kyle Ruddy, and I'm here on this session of Talking Code to cover how to get started with the vSphere Automation SDK for Java. Before diving right into the code, let's take a look at what the vSphere Automation SDKs are from a high level. So these are open-sourced software development kits, or SDKs, that are maintained by VMware in order to manage features that are available in the vSphere REST API as well as VMware Cloud on AWS. The goal of these SDKs are to provide a framework along with a bunch of samples so that consumers can get up and running quickly. The SDKs are available in languages such as Java, Python, Perl, .NET, and Ruby. All of these SDKs are openly available on GitHub, and we very much welcome any community contributions such as pull requests or logged issues. So let's take a look at getting started with the vSphere Automation SDK for Java. Here we are on my macOS system. We're at the vSphere Automation SDK's homepage, clicking on the Java button that takes us out to the Java repository. Scrolling down to browse the README a little bit, we can see that there are sections available such as the Quick Start Guide, links to API documentation, and even how to contribute samples back. Since we're just getting started, we're going to want to clone this repo locally by copying that URL from the clone or download button, opening up terminal, changing over to our directory where our cloned repos are, and doing git clone and pasting that URL. Next up, we want to verify what version of JDK that we're using. 1.8 is the preferred version. We have that installed. Now it's time to update our Java home variables. So doing export and then pointing to our JDK contents home directory, and then updating the path variable to include our Java home. Now we're ready to install Maven. So here I've included a curl statement on downloading the tar for Apache Maven 352. At this point we can extract that, move Maven to the app directory, and then clean up the tar that we downloaded. Now we'll want to update our path variable again to include the directory to the Maven bin. Changing over to our SDK repository here, our directory here, we will want to download all the dependencies for this SDK here locally. We'll do that with a MVN initialize. So since we haven't published our dependencies of this SDK publicly, this is just downloading those to make them available locally. Now that we have those all available locally, we'll do MVN clean install. This is actually going to install those dependencies that we have available locally. Now this part can take a little while, so we've sped it up just a little bit to make this easier to consume. So after that's complete, you see build success. We're now ready to get started. So next up, we're going to create a VM with defaults. We can specify Java, pointing at the jar file, and then the fully qualified class name there of create default VM. Here we have the help output, so we can see some of the requirements that we need to make this call. Here we have an updated call, including the vCenter name, username, password, VM folder, data store, data center, and the cluster-based information. So with all of that specified, we can now run this and create our VM with defaults. And what I mean by that is that it's taking out the guest OS type, which in this case is specified as Windows 9 64, and it is assigning information to that system. So we can see that we didn't configure a CPU or memory, disks, NICs, things of that nature. So this is all pulling that information back from the guest OS type. So here we can see our completed VM that's been created for us. Scrolling back up a little bit more here so that we can see all of the information. We created sample default VM. That's the VM's name. It has an ID of VM146. Then below we can see the output of the get. So we get that there's, this system has 1 CPU, 4 gigs of RAM, It has a hard disk that's stored on the vSAN data store like we specified. Now let's actually check out the code itself. Because understanding the code is very helpful to start integrating that into your own code. Opening up an IDE, in this case Visual Studio Code, we will then browse out to the file that we just called, which is create_default_vm.java. Opening that up and then expanding our view here a little bit so we can easier read this, we can see what was going on the back end. So scrolling down here a little bit, we can see some of the parameters that were required to be specified there, such as the data center, clusters, things of that nature. Then we can see the placement spec. And then we can see the actual call there for create default VM. It's going out, it's using some of that information from the parameters, creating creating the create spec. And then line 140 there is the actual create call. So that was a quick look at getting started with the vSphere Automation SDK for Java. In just a few minutes, we were able to download the SDK, install all of the prerequisites, and create a VM. More information about these SDKs are available at vmware.github.io/vSphere Automation SDK. Thank you.